there is a billiards ball in the form of a sphere initially at rest, and this is given a sharp impulse with the help of a cue generally used by the billiards players. The cue is held horizontally at a distance h from the central line of the ball, and the ball leaves the cue with a speed of, let's say, v naught, and it is known that because of the rolling and slipping nature of the ball eventually acquires the velocity of 9 by 7 v naught. Given the radius r of the ball, we need to investigate what is the height h above the central line of the ball at which this cue must hit the ball, so that the final velocity is 9 by 7 v naught. Now first understand that why will there be an increase in velocity, why will the velocity increase from v naught to 9 by 7 v naught. So the ball initially was at rest. When the impulse was imparted with the help of the cue, because of the momentum, both in the form of linear momentum and the angular momentum imparted to the ball, there will be an introduction of velocity v naught as well as let's say an angular velocity of omega naught in the clockwise direction of the ball. Now as soon as the ball starts rolling, what happens here is that if you see the contact point with the ground, there is a v naught in this direction, the velocity of v naught in this direction, and a velocity due to the omega naught, the angular velocity omega naught equal to r omega naught in backward direction. The ball is moving in the forward direction. However, understand that if this had been a pure rolling condition, the v naught should have been equal to r omega naught, and this point net velocity with respect to ground should have been 0, or this point should have been of the ball should have been at rest with respect to the ground. So this point would have been the instantaneous center of the ball. However, this is not the case. Because this is not the case, this velocity goes on changing and becomes 9 by 7 v naught. It's always the tendency of the frictional force which gets introduced because of the imbalance of r omega naught and v naught, so as to make the tendency of the ball to be that of pure rolling. Just understand that friction is a god. It's a god which always decides and wants the motion to be that of pure rolling. It adjusts itself in such a way, in such magnitude, obviously given the maximum value of the coefficient of friction between the 2 points of contacts. It adjusts its value from 0 to according to the coefficient of friction in between that, as well as in terms of direction, so that it always wishes that pure rolling occurs. So if the ball starts rolling, there is an introduction of frictional force, and that is the force that is going to help increase the velocity v naught to 9 by 7 v naught. So frictional force must be in the forward direction if it's going to increase the velocity v naught. What in turn is implied here is that if v naught is trying to support, if friction force F is trying to support v naught, it means that r omega naught initially would have superseded v naught. It means that r omega naught to start with should have been greater than v naught, and if that was the case, this point of contact's tendency was of backward slippage in this direction. So this is also called backward slippage. The tendency of this point initially was to slip towards back, but frictional force gets introduced and it helps the ball gain velocity and ultimately reach a position wherein corresponding to 9 by 7 v naught, there is such an omega that 9 by 7 v naught would be equal to r into that omega. That would be the case of pure rolling, and frictional force thus would have achieved its objective. So what is happening here? Once the ball if you understand the concept now, why is this ball changing its velocity from v naught to 9 by 7 v naught, and this is the frictional force which helps it do that, because it always wants. Here what frictional force is doing is two things. It's trying to increase the v naught, at the same time its tendency is to decrease the impact of r omega naught. This is what friction is trying to do, and this it is doing so that ultimately the velocity 9 by 7 v naught is reached, such that at a later stage some omega is found out, which is to be equal to r into omega, and this equal to 9 by 7 v naught. So this is the case of pure rolling, which will happen eventually. Now let's see what is happening here. If you see, the impulse is imparted to the ball, and let's say an impulsive force of F is applied, and omega naught is the angular velocity and v naught is the translational velocity of the center. From the linear impulse momentum theorem of the ball during the course of impact, I can write it, change in linear momentum will be what? Let's say mass of the ball is m, so m v naught final momentum minus initial momentum. This would be equal to force F. Let's say force F is applied by the Q for the impulse, and this should be equal to F into delta t. Delta t is the time in which the impulse was transferred to the ball and the ball started moving. So this is one relation. Now another thing is that since there is an angular velocity as well, we will look at the angular impulse momentum theorem about an axis passing through the center of mass of the ball and perpendicular to the plane of the ball. So from that we can write, this is my equation 1. My equation 2 would be from the angular impulse momentum theorem. So delta of change in angular momentum, delta L, can be given at by torque into delta T. So my change in angular momentum is momentum of inertia I about the center into omega naught angular velocity minus, since the ball was initially at rest, so initial was 0, torque into delta T. My torque, what is my torque about the center of mass? There is only one force whose torque action will not pass through the center of mass, and that is the force F itself. So F into the perpendicular height h into delta t. Now if you see from here, I already know F into delta t from equation 1. So let me substitute that. I will get omega naught is equal to mv naught h by IC. Right? Now this is one. From here on, the next way I can look at this problem is solving it through the equation of dynamics and forces on the ball and the free body diagram. But let's look at a probably smarter way, which will actually save time and be more conceptual in terms of solving this question. Now if you observe carefully, as all the forces acting on the ball pass through its lowest point once the ball is set in motion after losing contact with the Q, right? So if you see this point, there is this frictional force F, the weight of the ball mg, no force F any longer because it has lost contact with Q, normal reaction, etc. So the thing is that all the forces acting on the ball pass through its lowest point, and the direction of axis of rotation, if you see, also does not change. So we may say that the angular momentum of the ball is conserved about an axis passing through any point of the floor and perpendicular to the floor, perpendicular to the plane of the ball. So I can use the conservation of angular momentum instead of equation of dynamics here. So what I can say is, by angular momentum conservation, if I take the initial case, my velocity was v naught and my I had an angular velocity of omega naught. So I'm writing the conservation of angular momentum now. M from initial condition, m v naught into radius r plus ic, what was my angular velocity, omega naught. This must be equal to the final conditions angular momentum, which is my m into my velocity becomes 9 by 7 v naught into r plus ic. What is my omega? Now omega has also changed, as v naught has changed from v naught to 9 by 7 v naught. My omega has changed from again omega naught to such an omega where it's equal to 9 by 7 v naught by r, because this is the case of pure rolling, right? Now if you see here, I'm trying to write m v naught r. ic omega naught is something I already know from here, right? This is nothing but mv naught h. mv naught h is same as 9 by 7. If I take 9 by 7 v naught common, I have m into r plus, what is my ic? In case of spherical ball, my IC would be 2 by 5 mr square, right? So let's put that value, 2 by 5 mr square divided by r, so basically 2 by 5 mr, right? Now let's cancel out m throughout the equation. We are left with, and v naught as well, v naught can also be cancelled throughout the equation. So we are left with r plus h is equal to 9 by 7, r plus 2 by 5 r is my 7 by 5 r, 7 cancels, so this is 9 by 5 r. My r plus h is 9 by 5 r, so my h is 4 by 5 r. And this is what we set out to investigate. What would be my height from the central line passing through the center of the ball, such that the ball, which starts with an initial translational velocity of v naught, eventually gains a speed of 9 by 7 v naught. So this is my height h, which means I must hit the ball with the cue at a height of 4 by 5 r from the center, such that this condition is satisfied. Thank you.